Hi class, we are solving rational inequalities this time around. So for the first problem, we are going to solve this rational inequality. So remember, you have an irrational expression is when you have a polynomial over a polynomial, and it's an inequality because we're using the inequality symbol. So what we're going to do is we are going to solve this algebraically. So we're going to write the corresponding equation and set equal to 0. So we have 2x minus 7 over x minus 5 minus 3 equals 0 if I bring the 3 to the other side and change it to an equal sign. And I'm going to solve for x. So when I solve for x, I'm going to multiply every single term by the x minus 5 term to get rid of the fraction. So if I have my 2x minus 7 over x minus 5 minus 3, so I'm going to multiply this term by x minus 5 and the second term by x minus 5 and the right hand side by x minus 5. They cancel over there. So I have 2x minus 7 distribute the minus 3. Minus 3x plus 15 equals 0. Just go ahead and solve for x. You get minus x equals negative 8 when I combine and bring it over, or x equals 8. So this is one of the critical values, and we're going to find other critical values. So the where is the function undefined. So if I take my denominator and set it equal to 0, when x equals 5, the expression is undefined. So all of my critical numbers, my critical values, are the zeros, which is when x equals 8, and also where is undefined at x equals 5. So what we're going to do is we're actually going to write these in a list of increasing order so that we can write our test intervals. So we have 5 and 8. So we're going to set up our test intervals very similar, identical to the way we set up the intervals for the solving quadratic equation section. So our critical values were 5 and 8. So we're going to go from minus infinity to 5, 5 to 8, and 8 to infinity. So it's always from minus infinity to the smaller, between the two, and then from the biggest to infinity. So it's always round brackets around the infinities. And then since it's or equal to, we would use the square brackets generally. But if you look at this function, remember it was undefined at x equals 5, so it can never equal 5, because I plugged in 5 here, then it would be undefined. So it has to be a round bracket at 5, because I can't plug in 5, it would be undefined. So it's going to be a round bracket at 5. At 8, that was where, that was the x-intercept, the critical value when we solve for x. So if you're looking at the critical values where you solve for x, that is dependent on the inequality. And that's the same rules as we did with the quadratic inequalities. For the x-intercepts, if it's or equal to, it's round brackets, and if it was strictly greater than, not or equal to, it would be round brackets. So square brackets if it's or equal to at the x-intercepts. Okay, so it's round brackets where it's undefined though. Okay, so we have our x-axis, and we have the critical values 5 and 8. So we want to see, this is harder to visualize what this rational function looks like. So we want to see, is it up here, is it here, where exactly is it? So we have to pick an x value on this interval between minus infinity and 5. 0 is on the interval, so we should try 0. And we're going to plug it in to the inequality. You get minus 7 over minus 5. Is that less than or equal to 3? Yes. Because we have 7 over 5, and that number is less than 3. We need a number between 5 and 8. I'll pick 6. Remember, don't pick the endpoints. So if I plug in 6, I have 2 times 6 minus 7 over 6 minus 5, and I want to know, is that number less than 3? So you have 12 minus 7 over 1. Is that less than 3? No, because you have 5. A number between 8 and infinity, so somewhere in this outer section of the interval, like 10, for example. So 2 times 10 minus 7 all over 10 minus 5. Is that number less than or equal to 3? So 20 minus 7 would be 13 over 5. Is 13 over 5 less than or equal to 3? If I write 3, with a common denominator of 5, if I multiply it by 5 over 5, you get 15 over 5. So it's 13 over 5 less than or equal to 15 over 5. You could, of course, just plug 13 over 5 into a calculator. But 13 over 5 is less than 3, which is also known as 15 over 5. So yes. Now for the rational inequalities, you could get 3 yeses. You could have the first 2 yes and the second no. They can vary. That's different than it was for the quadratics. Okay, so the yeses and nos don't have to be yes, yes, or no, yes, no. Okay, so we're going to conclude. Where is our rational expression less than or equal to 3? Well, it's on those 2 intervals. Our conclusion is that the rational expression is less than 0 on the interval from minus infinity to 5. It cannot equal 5 because we plugged in 5 would be undefined, so it's a round bracket to indicate it cannot equal 5. And then from 8, it can equal 8 out to infinity. So 8 came from when we solved our equation, and it's an x-intercept. In the x-intercepts, we look at the inequality symbol to tell if it's square or round. Okay, so that would be our answer. Let's go ahead and move on to problem number 2, where we're going to solve this inequality. We want to know where it's greater than 0. So we're going to write the corresponding equation and set equal to 0. So we have 1 minus x equals 0. So to get rid of the fraction, when we solve for x, I can just multiply every term by x, and then it'll get rid of the fraction. So I have 1 minus x squared equals 0, or x squared equals 1. When I take the square root, don't forget you have plus or minus 1. So those are the 2 x-intercepts. So when we do our test intervals, we determine the brackets, round or square, based on the inequality symbol. Since it's strictly greater than, we know we're going to have round brackets here. Okay, so additionally, the additional critical values we're going to need is where the function is undefined. And if we look at our function, we can't plug in 0, so it's undefined at x equals 0 because we can't divide by 0. So we're going to list the critical numbers in order. So the x-intercept minus 1, the critical value where it's undefined at 0, and then the x-intercept at 1. So at the x-intercept, the critical value where it's undefined, you're always going to have the round brackets. At the x-intercepts, we look at the symbol, and that is going to be round brackets because it's strictly greater than. So we're going to have round brackets all over the place for the test intervals, and our critical values, once again, are minus 1, 0, and 1. So to write our intervals, we're going to go from minus infinity to the smallest, and then we're going to go from minus 1 to 0, 0 to 1, and I lost a row in my table, but we're going to go from 1 to infinity. So I'm just going to make an additional row. So here we have 3 critical values. You make your intervals the same way: minus infinity to minus 1 to 0, 0 to 1, 1 to infinity. So we're just breaking up our number line: minus 1, 0, 1. Okay, so we have the interval here, 1. Our second interval are the numbers between minus 1 and 0, our third interval, and then our fourth interval. So we have 4 intervals because we had 3 critical values. So our critical values split it into 4 different intervals. Okay, so we're going to need one between minus infinity and minus 1. So any number out here on the number line, like minus 2, for example, we're going to plug it in. 1 over minus 2 minus a negative 2. Is that number bigger than 0? So minus 1/2 plus 2, yeah, that's 1.5. So that tells me that this rational equation is above the x-axis there. A number between minus 1 and 0, you can never use the endpoints, so I'm going to use minus 1/2, and I'm going to use fractions because they're easier for me to deal with this division. So I have 1 over minus 1/2 minus a negative 1/2. Is that number bigger than 0? So 1 divided by minus 1/2 is negative 2 plus 1/2. Is that bigger than 0? No. Okay, so number between 0 and 1, that would be positive 1/2, because between 0 and 1, they're all the fractions. So I have 1 over 1/2 minus 1/2, and is that number bigger than 0? 1 divided by minus 1/2 is 2, minus 1/2 is 1.5, so yes, that number is bigger than 0. And then finally, number between 1 and infinity, you could pick 10. I'll pick 2, because that number's small, easy to deal with. So I have 1 over 2 minus 2. Is that number bigger than 0? So 1/2 minus 2 is minus 1.5, so no. So we have 2 places, so we're going to have our answer is minus infinity to minus 1 round bracket, union 0 to 1 round bracket. And double check your brackets. At 0, it cannot equal, and the square bracket indicates it can equal. So you need to make sure you do have the round brackets at 0. The other critical values from your x-intercepts, you look at your sign. Since it's strictly greater than, if it was greater than or less than, you're going to use round brackets. If it's or equal to, we're going to use the square brackets. So those are for the x-intercepts. So since our x-intercepts have the greater than symbol, it's going to be the round brackets, and that would be the answer. So it tells us on those 2 intervals, our rational function is bigger than 0. So I know if I were to graph it on the interval over here from minus infinity to minus 1, my graph is up here somewhere, and then between 0 and 1 is also up here. Okay, which tells me it's down here on the other 2 intervals. Okay, well, that is all. I hope you have a super great evening, and I will see you in class. Good night.